So here we have second problem. 0.25 kilogram aluminum bowl holding of 0.7 kilogram of soup at 23 degrees Celsius is placed in the freezer. What is the final temperature if 390 kilojoule of energy is transferred from bowl and soap, assuming the soap's thermal properties are the same as that of water? So answer has to be given in Kelvin. Okay, so basically we have a bowl and a soap at 23 degrees, and then it has been placed in the freezer. Okay, when it has been placed in the freezer, we know the temperature of the freezer is below 0 degree, so it might be minus 23, minus 15, we don't know. Okay, and then it says that 390 kilojoule of energy transferred, or in other words, it has been extracted or taken from this whole things. And when it was taken, you have to know what is the final temperature of the whole thing when it's at freezer. Okay, so we have to know a couple of things before solving this thing. We know that we have two objects. One is the bowl, which is made from aluminium, I think, and then we have a soup. So soup you can consider as a water. So if you look at the both things, what will happen is that it will go through 3 stages. Okay, the first, from 23 degree, it has to go to 0 degrees Celsius. That's what you have to calculate it. After that, the soup itself, it will go through phase change. Okay, so at 0 degree, it will soup or will go or could be converted into ice. Okay, which is called phase change to make it ice. Then after that, once it's ice, then from 0 degrees Celsius, it will go to the final temperature, which might be minus 10, 15 or whatever. Okay, so let's start solving it. So first of all, we have to know how much heat is released or taken from bowl and the soup when it cooled down from 23 degree up to 0 degrees. Okay, that's what we have to calculate it. So in that case, you have to consider both of them. So mass of the bowl, specific heat of the bowl, plus change in temperature, change in temperature, plus mass of the soup, specific heat of the soup, and delta T. So we know that it goes from 23 degree till the 0 degree, okay, when it's cooled down. So we have to plug the numbers. So this is T final, which is 0, T initial is 23. So you put all these numbers, and then we got negative 72.569 joules. So as I said, this negative sign just means that the heat was released, okay, when it cooled down. So when you're calculating in the final things, just ignore this negative sign. Then after that, what will happen? In the second stage, the soup will go into the phase change, okay, from liquid to the ice. So that's what we have to calculate. So in this case, you're just considering only the soup, because the metal bowl will not go into phase change, okay, because it's not liquid. So Q2 is equal mass of the soup and latent heat of the fusion of the soup. So you do calculate it, and you got that this amount of heat is basically released or extracted to go through phase change. Okay, so far we have positive this one and then positive this one. If you add this both of them, it's still less than this amount of heat. Okay, so that means it will further cool down. So then in the third stage, we are further cooling down. Temperature drops from 0 till negative degree Celsius. Then in the third case, we have to know that both of them, bowl and soup, will go below 0 degree. So mass of the bowl, specific heat of the bowl, change in temperature, mass of the soup, specific heat of the soup, and change in temperature. Okay, then what you do is that 0.25 multiply this one minus T final minus 0, and here same minus T final minus 0, and then you calculate it. So when you calculate it, again, just ignore this minus sign. Just minus sign means energy is dropped. Okay, so we have 1688 multiplied to final. At the end, you just have to sum all this heat which was removed to cool down. Okay, and then you have to equalize to Q transferred, which is already given here. So you put all these things and T final here, and then you can calculate that T final is basically positive, or so not positive, but you got positive here, 49.53 degrees Celsius, and you know that it definitely should be negative. So when you're converting into Kelvin, so in Kelvin is basically 273 minus 49.54, so that gives you this amount of temperature in Kelvin.